Hello, researchers. My name is Malcolm Shambana, and I'm here to take you once again in research methods. And today we are looking at hypothesis testing. This is testing for inferential statistics. If you haven't seen the video for inferential statistics, it's best you go to one of my videos under my YouTube channel. You search for that video so that you have a background of what exactly we are doing today. So as for now, you may sit back, relax, and enjoy as I take you through hypothesis testing. Thank you all. My name is Malcolm Shambana. You can reach me on +260-977-488-442. That's a Zambian number. You can send me WhatsApp or text, or you can even call me if you can manage. You can watch other videos and you can subscribe to my YouTube channel for notification if in case there is a new video. You might as well like the video so that it gives notification to your friends that there is such a video. You might as well ask me questions on my line or even on my comments. You can send comments on my YouTube channel and there I'll definitely respond. So our learning objectives today is to understand what hypothesis testing is, also to know the types of hypothesis tests, to know the types of errors which you may incur during your hypothesis testing, to understand the steps involved in hypothesis testing, also to know what a test statistic is. So we move on to where we get our hypothesis test. Remember, initially, when doing your types of your research methodologies, we mentioned that there is qualitative research, which begins with a question, then you go to your observation or interpretation of your observation, and then you develop your theory or hypothesis, which later on we discussed the deductive methods, which involve now the test of your hypothesis, measuring of your hypothesis, and confirming whether the hypothesis is correct. And that was done through quantitative method. So now the question is, what is an hypothesis? A hypothesis is a claim or proposition or prediction made on limited basis, and it can be tested, or it has to be tested. Hypothesis can be derived from a research question, like I've earlier shown through those diagrams in the earlier slide. The research problem, for example, may be Zambia has experienced drought in the year 2024 and has since been declared a national disaster by the Republican president, as this will have a negative impact on the country's economy. So the hypothesis there would be drought has a negative impact on the Zambia's economy. That's a preposition or a claim or a prediction. And this can be tested for confirmation. There are two types of hypothesis tests. There is what they call the null hypothesis, which is the claim that has been established. For example, the null hypothesis is that drought has no impact on Zambia's economy. Then we have the alternative hypothesis, which is the opposite of the null hypothesis. The alternative hypothesis, in this case, we can give an example. Drought has a negative impact on Zambia's economy. Please note that the new hypothesis testing starts with an assumption of no difference between groups or no relationship between variables in a population. That's why our new hypothesis in this case begins with drought has no impact on Zambia's economy. Instead of drought has impact on it starts with, that's why it's called null hypothesis. There is zero. Zambia has no drought has no impact on Zambia's economy. That's how you start your null hypothesis. It starts from zero or new. And then the alternative hypothesis is just the opposite of the new hypothesis. So the null and alternative hypothesis are commonly denoted as H or zero, not O, actually it's zero. Sometimes I've seen that's just a common denotation. Sometimes some use H with subscript 1 instead of 0. An example is HO. Average inflation will be less than 5%. That's your new hypothesis. And then the alternative hypothesis is commonly denoted by HA. A, H subscript A, which the A stands for the alternative. And then an example is HA. Average inflation will be greater than 5%. Those are examples of how the hypothesis appears. Now, if you remember that we are testing data or information from a sample, and the sample is gathered in order for you to infer or determine the characteristics of the entire population. You pick a sample so that you know the qualities or features of the entire population. And usually, when it comes to sampling, there's a high likelihood that there will be an error in your conclusion about the entire population because you have just sampled, you have just picked a few elements of the population, of the actual population. So that results in error during your hypothesis testing. You may come up with a confirmation of a hypothesis which are not correct because you are not using the actual population but a sample. And these types of errors, there are two types actually, types of errors which you may incur during your hypothesis testing. There's type 1 error, which involves rejecting the null hypothesis when it's actually true. There is also type 2 error, which involves failing to reject the null hypothesis, which is false. I can illustrate this through a table. The first row definitely is talking about the null hypothesis. The second row is talking about the condition, the reality of the null hypothesis, whether it's true or it's false. That's the reality of the null hypothesis. And then the last two columns, there are three columns, but the last two columns, they're actually talking about the judgment which you make as a researcher, which you have made as a researcher. So in this case, if you reject the null hypothesis, which is true here in this cell, then you would have made a type 1 error, also known as false positive. And it's denoted by alpha. It's a probability actually for you rejecting the null hypothesis, which is true. And then, in a case where the null hypothesis is true and you fail to reject that null hypothesis, then you have made the correct decision. And that is known as the power of test. In the situation where you have a false hypothesis, in reality, the hypothesis is false, and you make a decision of rejecting that hypothesis, then you have made a correct decision. And that probability is 1 minus alpha, which is the probability of rejecting the hypothesis which is true. Then, in a situation where you fail to reject a hypothesis which is false, then you would have made type 2 error. You have failed to reject the hypothesis which is false. Then you would have made a type 2 error, which is denoted by beta. That probability of making that error is denoted by beta, as indicated in the diagram. So we come to our examples of the types of errors in hypothesis testing. I'll give you this common one. It's called the court case. And in a court, there is a reality and there is judgment. So in our case, the reality, there is the hypothesis, which is in this case innocent, guilty. These are reality situation. That's the real situation. So there is also the judgment, where you are found maybe a criminal is found guilty or innocent. There's a situation where the reality is the criminal is innocent or the criminal is guilty in reality. There is also in judgment, the criminal is innocent or the criminal is guilty. That's in judgment. So, when you make a judgment of guilty on a reality, where in reality that person is innocent, then you would have made a type 1 error. Again, when you make a judgment of guilty, when that person is actually guilty, then you would have made a correct decision. So in the first scenario, you're going to be jailing an innocent person, where you say the person is guilty. In reality, that person is actually not guilty, is innocent. Then you're going to jail an innocent person, and that's a type 1 error. And then in the second case, where you have made the judgment of guilty, you have concluded that that person is guilty, the criminal is guilty, and in reality that person is actually guilty, then you would have made the correct decision and you'll be jailing a guilty person there. Again, another judgment is you can declare somebody innocent, and in reality that person is innocent. Then you would have made a correct decision by freeing the innocent person. Again, in this other situation is you may declare that person innocent, and in reality that person may be guilty or is actually guilty. Then you would have made a type 2 error, freeing a criminal. We come to example 2. This also has become a common example, a COVID-19 case. Remember, we had a serious health issue which started in 2019 and extended to 2020, 2021. So we lost so many of our loved ones. May their soul rest in peace. But I'll still use this as an example. Um, in table form, of course. It's similar to the previous example, but this one is more on the healthy matter. So the situation we have here, where somebody, for example, there is diagnosis, there is the reality, the hypothesis. In reality, a person doesn't have COVID, is not positive. That's the first column. Sorry, the second column. And the third column, in reality, the person is actually positive. And then we have also the judgment, the diagnosis, the conclusion by the medical doctors is that the person is positive or the person is negative. So, in a situation where in reality the person is actually not having COVID, doesn't have COVID, is actually not positive, and the doctors conclude that is positive, the doctors would have made a type 1 error. And in the second situation, where the doctors conclude that that person is positive, and actually in reality that person is positive, then the doctors would have made a right conclusion. Type 1 error may result in maybe a person being given medication unnecessarily, whilst that person is not positive, and they may have other consequences. And then in the other case where we have positive, where the medical doctors conclude that the person is actually positive, and in reality the person is positive, definitely they would have made a right decision, and that person would be given correct medicine. The other situation is where the doctor say the person is not positive, and actually in reality that person is not positive. Then the doctors would have made a correct decision, and they won't even dare to maybe start giving medication to that person. Again, there is a situation where the doctors say that person is not positive, and in reality the person is actually positive. The doctors would have made a type 2 error, and this may be fatal because that person won't be given treatment or any medication, and may result in death. And this was a common situation. Some people, some tests failed to detect the COVID in people, and these tests actually can be extended to other tests. For example, malaria tests. You can give an example in a case of malaria test, the person is said not to be positive, but actually that person is positive. Sometimes the test may fail to detect the virus or the bacteria. So those are the two examples. Now the common question is which one is fatal? Type 1 error or type 2 error? Some say type 1 error is fatal. Some say type 2 error is also fatal. But what I can say myself is it depends on the situation. Like in this case, in a medical case, type 2 error seems to be more fatal because that person won't be treated. So it depends on the study you are doing. Is it a science? Is it a natural science or a social science? The early example I gave on the prison, an innocent person being arrested or imprisoned due to wrong judgment may be fatal. But in that case, it was a type 1 error. So it depends on the study you are doing and the consequences involved in making a particular error. So there are decisions which we make based on the errors, the types of errors, and these decisions affect our hypothesis test results and confirmation. So the types of errors are actually used in your hypothesis. You have to put a markup on the levels of the errors you expect during your hypothesis testing. There is a markup, a cutoff point. Let me put it that way. Type 1 error and type 2 errors are inversely related. If one increases, the other one decreases, or the other way around, or vice versa. So it is desirable to reduce both errors, but only one error can be reduced. And usually type 1 error, which is alpha, is easier to measure compared to type 2 error, beta, which is beta, which requires the test distribution of the alternative hypothesis. And the information about type 2 error is usually not available. You don't have those statistics or the actual distribution. I won't go into those details, but today I just want you to understand how hypothesis is done. I won't go in. That's why I won't even show any formula today to avoid misunderstanding. Today is just the idea is for you to understand what you need to do when testing and how you need to conclude. We come to steps involved in hypothesis testing. Uh, to begin with, you need to state your now hypothesis and the alternative hypothesis. Those have to be stated. That's the first step. I gave examples earlier on. If you want, you can still go back to them. You can pause the video, you go back to them so that we are on the same page. You need to choose now the level of significance. Here, what we mean by the level of significance is the level at which you are going to accept the results. The level at which you are going to accept or reject the null hypothesis. And this level of significance is actually type 1 error. And usually it's set at 5%, which means you have got you want your error only to be at 5%, and then your results, you want your confidence in your results to be at 95%. That's an example. Those figures are examples. So you are using type 1 error as a markup, as a cutoff point. You don't want your error to be maybe 15% or 20%. You just want your error to be at 5%. You set that level. Or you want your error to be at 1%. This is part of your steps in your hypothesis. You need to set the level of your error, making an error type 1 error. You need to set it. Then you also determine, after setting that error, you determine how you are going to reject the hypothesis. If your results, the results are beyond the error, there is a point where you need to reject those results and reject the existing hypothesis because of the results which you are going to come up with from the test statistics. We'll go into test statistics shortly. Then there is also, you need to calculate the test statistic where you compare what data you have to the markup, the level of significance which you have. In short, you are comparing the score of the data which you have gathered about a particular population through a sample, the data which you have gathered about a particular population through a sample. You want to confirm if it's acceptable according to the error, the type 1 error which you have set. The score of your results, how have they scored, and the markup coming from the error you have set. I won't go into those details. I'm just explaining the steps. We are not doing any calculations. But you come to understand this much better when we start doing the calculation. And this will be in the next session. We'll try to do some example of test statistics. Of course, not using formulas, those statistical formulas, but we'll use the existing, maybe Excel. Will you do that in Excel? That's when you are going to understand better these levels of significance and test statistics, because actually we're comparing the two. What you have scored through your data and the markup which you have set, or the cutoff point which you have set. Have we reached the cutoff point or we are below the cutoff point? That's the idea behind hypothesis testing. Then you decide whether the null hypothesis should be rejected or fail to reject the null hypothesis. Then you state your conclusion. Those are the 6 steps which you're going to be involved in during your hypothesis testing. From those steps, we have mentioned setting up your new and alternative hypothesis. We have also mentioned the significant levels, setting up your significance level, which comes from your type 1 error, which is alpha. We also mentioned your test statistic. A test statistic actually measures how close the observed data from your experiment is to the new hypothesis. How close is the data to your new hypothesis? It measures the consistency of data to your new hypothesis. Does your data agree with your null hypothesis? That's a question. It's usually in a formula, but since this is research method, we won't go into details of the formulas because we will use other methods to test your hypothesis. But for example, we are going to use Excel, but within that Excel, there is a formula which relates to each whatever statistic you are doing. So the test statistic you are going to use, you can know, there are several test statistics you use depending on the situation, and each test statistic depends on several conditions. How you choose your test statistics, you have to look the condition of your research, your data. Example is that your test statistics will look at the probability distribution of the sample means you are taking. For you to choose the test statistic to use, you look at the probability distribution of the sample. You also look at the sample size when deciding which test statistic to use. You look at the sample size. You also look at whether the population standard deviation is known. For you to decide which test statistic to use, you check whether the population standard deviation is known. If it's not known, another test statistics is used. If it's known, another test statistic is used. We'll go into those details. You also look at the number of variables involved in your research for you when deciding which test statistic to use. Do you have maybe categories, maybe there are provinces, 9 provinces or 10 provinces. Now in Zambia we have 10 provinces, then you are comparing those provinces. Or you are looking at gender, then you are going to have maybe two variables, male and females. The number of categories, variables matter when choosing your test statistic. Also, the type of variables you are dealing with. Is it numeric or their categories? Are they in test scores results, or are you looking at gender, male, female? The categories. They also matter which test statistic is. There is an example which I gave when doing your inferential statistic. You need to go to that video. It's still there on my YouTube channel. Please remember to subscribe so that you are up to date with your research methods. In that example, I've brought the table back. We used these t-test, ANOVA, and chi-square, and correlation. These are test statistics. especially the first three: t-test, ANOVA, and chi-square. Please, as for now, you can ignore the correlation because this one doesn't result in a probability distribution or assessment, or it's not affected by, but it results in a number between 0 to 1, which is an effective size of maybe when you're comparing two variables and the impact. You're looking at the size of the impact. So we are concentrating on these: the t-test, ANOVA, and chi-square. These are your test statistics and when to use them. In the example I gave earlier in your inferential statistics, you use t-test when you have two categories. Then you also use t-test when your dependent variable is numeric. For example, exam score. Again, you use ANOVA as your test statistics when you have more than two categories. For example, we had provinces: Lusaka, Southern, Wapura provinces. Then we used ANOVA when our dependent variable was numeric. Have you seen how these factors affect which test statistics you use? So you need to be careful when choosing a test statistics. You look at such factors: whether you have two categories and a numeric or dependent variable, or whether you have more than two category and a numerical dependent variable. You choose which test to use. Then there is also chi-square as your test statistics. There you have the independent variable is categorical, it's in words, and the dependent variable is also in words. Then you use chi-square. So this is the example I've given in a situation where you are choosing which test statistic to use. Does it have numbers and the type of variables? Then there is also in situations where you have to decide whether to use the t-test, or there is also what is known as the z-score. There are also conditions where you need to choose between t-test and z-score. Those conditions may be maybe the sample size, or whether the standard deviation of the population is known. If the standard deviation of the population is known, then you use the z-score. If it's not known, you use the t-test. Please take your time, go through these conditions and when to use a particular test. Take your own time. If you have any questions, you can still send me those questions. You can contact me via WhatsApp. You can say right on the YouTube as a comment on the YouTube channel. Then we can resolve that together. So those are the items you need to be looking at. These are, I think this is an extension of the example. For example, we have the new hypothesis where the exam score between two provinces. We have got two items there, the Lusaka and Southern province. So you need to decide which test you need to use, which means we have two categories there, which means we are going to use the t-test. However, you may not use the t-test if you have the two categories, but you also know the population variance. Then you have to use the z-test. Go through these conditions, same as ANOVA. You have three categories. Then you set your level of significance, which is your level of type 1 error. That's your markup. If your score goes beyond that markup, then you make a decision, and so on and so forth. Please, I know I've said so much regarding this. You understand when much better when we start doing examples. So please subscribe so that you also get notification on further sessions regarding these tests, which you may use in your research, your dissertation, and thesis. Thank you very much for sparing your time to listen to this slightly long session. God bless you all. Thank you.